All right, so I'm just going to go ahead and kick this off. So an overview of the mirroring enhancements introduced in 10.7. There are two enhancements to existing portions of the mirroring solution and one new feature. So the new feature introduced is the remote mirror endpoint. This allows you to use an AOS-CX switch to terminate a remote mirroring session sourced from another CX switch. This decapsulates the encapsulated ER span mirrored traffic from the source switch at the destination and forward it to a destination, one or more destination ports on the endpoint switch. This is great for allowing you to use remote mirroring, just like was available on AOS switch devices, to send mirrored traffic to a capture station on a remote switch, and I'll go into more detail here in a bit. The other two enhancements are adding VLANs as a mirroring source on the 8360 and 8400, and multiple destination ports per mirror session on 8360, 6200, 6300, 6400. So I'll go into a little more detail on all of these here in just a slide. So what are the use cases for these new features? So remote mirror endpoint allows you to use a single destination switch to decapsulate and forward your encapsulated mirror packets from your source switch. So here, instead, we have your source device, which is a running switch monitoring one or more interfaces and sending the mirrored packets across a tunnel interface to a destination port where that mirrored traffic is being decapsulated and forwarded on to up to 32 sessions to destination ports on that endpoint switch. This allows you to send traffic from a single source switch to multiple destination ports on your endpoint switch, as well as to use that to capture traffic from a capture station or utility that is not directly capable of decapsulating those packets itself. So for example, Wireshark can be used to decapsulate packets mirrored from an ER span source device directly, but there are capture utilities and app monitoring applications that are not capable of doing that decapsulation themselves, so they can't monitor that traffic directly. So this feature will allow you to terminate that encapsulation before the mirrored traffic actually reaches that utility or application. So it enables you to use the remote mirroring to capture traffic from a source switch, even if your application is not capable of directly receiving those packets. So the other two enhancements, mirror source VLAN allows you to monitor traffic from multiple source ports sharing a VLAN without needing to specify as monitor ports those individual interfaces, as well as preventing you from the need to filter out traffic from other VLANs that you're not specifically monitoring. So this allows you to basically specify your VLAN as your traffic source for monitoring purposes. And again, this feature is specific to the 8360 and 8400 switch series. Multiple destination interfaces per session. We have had customers specifically requesting the ability to forward mirrored traffic from a single session to more than one destination interface. Some cases there are customers who are using an application or multiple applications that need to take the same mirror source traffic and then send it out to multiple platforms that are being used for network monitoring purposes. And they using mirror sessions to do that was not flexible enough. So now we support up to 64 destination ports for each mirror session on the switch models listed. So the 62, 63, 6400, and the 8360. These are all switch models that use our Rosewood ASIC because this is an ASIC dependent feature. The majority of this session, however, is going to focus on the remote mirror endpoint because this is a brand new feature that is being introduced in 10.7. So let's just go ahead and dive right into this. So remote mirror endpoint supports termination of the ER-span GRE remote mirror traffic that originates from another Aruba CX switch. Future releases may support other encapsulation formats. For example, the HP encapsulated remote mirroring or HPERM format that is used by AOS switch or PVOS for older switch releases. But as of 10.7, we support ER-span GRE encapsulation for this particular feature for decapsulating mirrored packets from a source switch. So this feature specifically requires AOS-CX 10.7 on both ends of the switch or both ends of the tunnel. And one particular note is that as of the 10.7 release, the ER-span GRE header from the source traffic being tunneled to the destination switch has a tunnel ID value that is set to the mirror session ID from the source switch. So session 1, 2, 3, or 4. When you're configuring the mirror endpoint on the destination switch, that tunnel ID is what you use to determine which tunnel, if you have multiple tunnels coming in to the destination switch, the tunnel ID is what's used to determine which particular tunnel source to decapsulate for the mirror endpoint you're configuring. And I'll show you the details of that in just a bit. Mirror endpoints are different from mirror sessions. So you have 4 mirror sessions that you can configure on a given switch. Endpoints are a totally different feature. They do not use the mirror sessions at all. You can configure up to 32 mirror endpoints on your destination switch, each of which forwards its packets to a different set of destination interfaces. And once again, this is supported on switches with the Rosewood ASICs. So that's your 62, 63, 6400, and your 8360 switch. And going back to, actually the prerequisites are in later slides, so I'll show you that in just a bit. So some caveats for the remote mirror endpoint feature. First off, your endpoint destination interfaces where traffic is forwarded after being decapsulated. You cannot specify lag member interfaces as a destination. You can only specify the lag itself. So lags are supported, but you cannot use a lag member interface as your destination port. Interfaces on the endpoint switch, you can only assign an interface to one endpoint instance at a time. Mirror traffic cannot be encapsulated within another tunnel. So on your source switch, if you designate a destination for which the only path from the source switch to the destination switch is an existing tunnel interface, the switch will not enable that mirroring tunnel session because you can't encapsulate, can't have double encapsulation basically. So you would need to have a separate interface over which the endpoint is reachable that is not tunneled. You cannot use the OBM interface as a remote mirror tunnel on either the source or destination. And lastly, you cannot use an interface for both S-flow and as a mirror source that is mirroring received traffic, either only received or traffic, bidirectional traffic. So whichever feature you apply first to that interface, either as a mirror source for received traffic or bidirectional or S-flow, whichever one is applied first will preempt you from applying the other features. So you will have to disable one of those to enable the other one. And if you did have both of those features enabled on an interface in a switch startup configuration and the switch reboots, it is non-deterministic which one is applied to those interfaces. So either one, whichever one the switch happens to apply first during startup is the one that will stay enabled on that particular interface. So configuration for remote mirror endpoint. Prerequisites. So once again, this is only supported on the Rosewood ASIC switches, 62, 63, 64, and 8360, running AOS-CX 10.7. Remote mirroring without the endpoint decapsulation is supported on every CX switch and software version released except for the 6100. So 6100 does not support remote mirroring at all. All other switch models support it from their initial software releases. The new feature introduced here is specifically to decapsulate the remote mirror packets on the switch itself.
Yeah, Matt?
Yes.
There are a couple questions here about what happens with remote mirroring in the endpoint if the source is an AOS switch. Have you had
it does not that does not work. So the only encapsulation that we support in AOS-CX 10.7 is ER-span, which is what CX uses for remote mirroring. AOS switch uses a protocol known as HPERM, encapsulated remote mirroring, which is a completely different format, which CX does not support as of 10.7. As I mentioned in the details page, I'll go back to that slide. We are considering different encapsulation formats in future releases, but the only encapsulation supported in 10.7 is ER-span GRE, which is what CX itself uses.
Perfect, thank you.
Mm-hmm. So second prerequisite, you have to have IP reachability between your source and endpoint switches. So you have to be able to tunnel that remote traffic from the source to the destination. If your tunnel interface is the same port that you're using for both mirrored and user traffic, use caution to make sure that your mirrored traffic is not causing you to exceed the available bandwidth. That would kind of defeat the purpose of network monitoring if your monitoring solution is impacting network performance. And then all destination interfaces or lags for each endpoint on the destination switch have to be members of a common VLAN, and that VLAN should only be used for interfaces on that specific mirror endpoint. So each endpoint destination port, or rather all ports on each endpoint destination you configure, should be members of a VLAN that only exists on those ports and none other. This is basically so that you can isolate those ports from traffic that's being broadcasted on other VLANs on the switch, so that you're not capturing user traffic in addition to the traffic you're monitoring on your destination ports. And then you want to make sure that the MTU you have configured on that common VLAN matches the MTU of your source interfaces on your source switch, so that you're not dropping traffic that's larger than that configured MTU. The default value is 1500. So if you have jumbo frames, frames in excess of 1500 on your source switch, you want to make sure that that MTU is also configured on your destination ports. All right, so how do you configure this? Pretty straightforward. We start with the source switch configuration, which is the one that's highlighted here or outlined on the left. First thing you do is create your mirror tunnel session on switch 1. So you create mirror session 1, you configure the tunnel with your switch 2 IP address as your destination and switch 1's IP as the source. So you have destination tunnel 192.168.254.1 with the source 192.168.254.0. So on your source switch, you do the destination IP first, and then the source IP second. This becomes important when you're configuring the endpoint, the ordering you're putting those in. We specify an interface, one of our interfaces as the mirroring source. In this case, we do port 1148, and then we enable the mirror session. Pretty straightforward. Now we move on to switch 2, and that's the endpoint configuration where we're going to decapsulate the mirrored packets that are being encapsulated on switch 1 as it leaves the switch in transit to switch 2. So the first thing we're going to do is we're going to create that isolated common VLAN and assign it as an access VLAN to interface 111. So this is the interface that our capture station is connected to that we'll be using to see the captured packets from port 48 on the source switch. So we create VLAN 999 in this case, and we assign it, we give it a name so that we know what this VLAN is for, and we assign that VLAN as an access VLAN on our destination port, which is port 111. Once we've done that, now we create the actual mirror endpoint. So we just create mirror endpoint, endpoint 1. We configure the source and destination IP address and the tunnel ID for the remote mirror session from switch 1. So we do source 192.168.254.0, which is switch 1's IP, destination being switch 2's own IP address, and ID 1, because we are using this for mirror session 1 on switch number 1. If we were using mirror session 2 or 3 or 4, we would put that mirror session number as the ID for this configuration. We specify destination interface 111 for decapsulated mirror traffic, so destination interface 111, and then we enable the mirror endpoint by doing no shutdown. Once you have the mirror session enabled, then you have your capture station running on your connected to your destination port using something like Wireshark to verify that your traffic from your source port, port 48 on switch 1, is being properly forwarded, decapsulated on switch number 2. And you can verify that that is happening properly by disabling the mirror session on the source switch and verifying that your destination switch port is no longer receiving those encapsulated captured packets. So let's go ahead and jump right into a demo here. Let me get this out of the way. So I've got a pair of 6300s, and you can see my interface configuration, port 25, switch number 1 has 192.168.254.0, and switch 2 is 192.168.254.1. So it's /31 that I'm using as my transit VLAN for the remote mirroring. So we're going to start by doing mirror session 1, destination tunnel 192.168.254.1, source 192.168.254.0. So destination first, source second. My source interface is going to be port 1148. Both directions. And then we're going to go ahead and just enable this right now. So that's the source side. So now this switch is capturing packets from port 48 and forwarding them in a tunnel to 192.168.254.1. And so here we need to configure our endpoint to decapsulate those packets. Before I do that, I'm going to go ahead and pop up Wireshark here. And I'm going to start by creating my isolated VLAN so that the capture on my laptop here is not capturing any packets from VLAN 1. So let's do VLAN 999, give it a name.
Matt?
Yep.
There was a question there. If instead of using VLAN 999, you could use a routed port there?
So the destination port has to be L2, which is a VLAN. Perfect. So the transit between the two can be a layer 3, can be a routed port, and in fact is a routed port on both ends of the switches. So the tunnel that's transiting between switch 1 and switch 2 in this instance is a routed interface on both ends. The endpoint, on the other hand, has to be layer 2, which means has to be a VLAN on the destination switch specifically.
Good, thank you.
Mm-hmm. All right, so we're going to assign interface 111 as an access VLAN on the VLAN we just created. Head and back out, and I'm going to start the capture on the laptop here. So we can see we're basically picking up almost no traffic on this interface here. That will shortly change. So let's go ahead and create our mirror endpoint. Endpoint 1, source 192.168.254.0, which is switch 1's IP. Destination 168.254.1, ID 1. Destination interface 111. And as soon as we do no shutdown, watch what happens to the capture on the left. Immediately, we start seeing that, that traffic being captured from port 48 on switch 1. And we can verify that that's where this traffic is coming from. I mean, it's pretty obvious. We just enabled the endpoint on the destination switch, but we can verify that this is where this traffic is coming from by, on the source switch, disabling the mirror session that we just completed the endpoint for, and disable. And there we see packet 322, our capture basically stops. Enable it again, and now we're capturing traffic again. So it's pretty simple to set up, pretty straightforward, and it gives you that much more flexibility for monitoring traffic between AOS-CX devices end to end, while being able to forward that mirrored traffic to multiple destinations if your setup requires that. Go ahead and just disable that. And let's hop back into the presentation.
I have a couple questions here. Have you
Certainly.
or do you know if we support IPv6 encapsulation for ER-span?
That I do not believe we support. You're talking about using IPv6 as the source of destination for the tunnel interface?
Exactly, yep.
I do not believe we support that in this release. Tunnel. Yeah, only IPv4 in this release.
Okay, makes sense.
Pretty sure, just wanted to verify that.
Yeah, and the only other thing that I would say is, so when you configure the endpoint at the receiving end, you set an ID and you used ID 1. And I understand that that refers to the mirroring session that you created on the source. That's the same number, right?
Correct. The ER-span GRE header that is used to encapsulate the packets has the mirror session number as the tunnel ID in the at least in the 10.7 release. So for the initial release, at least, that is what is used for the ID on the endpoint. A future release may support multiple tunnel interfaces with explicitly defined IDs used for the endpoint configuration. But in 10.7, what the developers told me is that the session number on the source switch is what is used for that ID tag.
Okay, and there's another question here about on the destination switch, on the receiving side, can you send the traffic to the CPU?
You cannot use the CPU as a destination on the endpoint switch. You can only specify interfaces or lags. So no VLANs, no CPU. It only goes to an interface or lag, or one or more interfaces or lags that you define.
Exactly. So you're basically receiving it, decapsulating it, and sending it out the port.
Correct. If you needed CPU capture, yeah, I can't really think of a way you could do that, because on the source switch, your options are either interfaces or I don't believe you can specify both CPU and tunnel as destination, but we'll do some testing and verify that that behavior and get back to you.
Mm-hmm. Thank you.
Mm-hmm. All right, so back to the presentation. All right, troubleshooting and debugging remote mirror endpoints. So if you are not receiving your traffic on your endpoint switch as expected, you're not receiving it at all, or it's not being decapsulated as you're expecting, or you're not seeing all of the traffic that you expect to see Here are some things to verify on your configuration on both ends of your remote mirror tunnel. First, you want to make sure that the mirror session on the source switch is configured with tunnel as the destination. Your source and destination IP addresses are the same in the mirror config for both the source and endpoint destination switches. And this is where where it's important to note the order of the IP addresses on each end. So on the source switch where you're configuring the mirror session, it's destination IP first and source IP second. On the endpoint, it's the other way around, where you specify the source IP first and destination IP second. So the order is swapped on each end of the tunnel. Make sure your mirror session and mirror endpoint are enabled on each switch respectively. So you have to have the sessions and endpoints active on both ends. The MTU on the common VLAN matches the largest MTU on any monitored interface on the source switch. The default, if not explicitly configured, is 1500. So if you don't have MTU configured on the endpoint switch and you have packets greater than 1500 bytes on the source switch, those packets get dropped at the endpoint. So you have to make sure that the MTU matches the largest MTU on the source switch, and then make sure that your endpoint destination interface VLAN is not assigned to any non-mirroring interfaces. So that VLAN should be used for those destination ports and only those destination ports. And you should have a different VLAN for each endpoint destination. Show and clear commands, you have show mirror and show mirror endpoint. So this gives you show mirror by itself without an ID, just gives you a summary list of your mirror sessions, whether they're admin enabled, disabled, and actually operating enabled or disabled. Show mirror with the session ID gives you more detailed information, including statistics, how many packets and bytes have been captured by the mirror interface and forwarded to your destination, which in this case is a tunnel. Show mirror endpoint, kind of the same deal, without an endpoint name, just gives you a summary list of all of the endpoints you have configured. And then show mirror endpoint with the endpoint name gives you the detailed information, just like the mirror session ID here, which includes your tunnel configuration, source, destination IP addresses, and tunnel ID, the destination interface or interfaces configured for this endpoint, and your packet counters for the mirroring session on the destination end, which should, if assuming that you started them both at around the same time, or you've reset the statistics at about the same time, the packet counters, packet and byte counters here should roughly match the packet and byte counters on the other end. And then you have clear commands for both mirror and mirror endpoints to clear your statistics for each of those. Diagnostic commands, there are two. You have diagnostic dump for mirror basic, which is basically the software debugging information for mirroring sessions or mirror endpoints on each switch. And then you have mirror ASIC, diag dump mirror ASIC basic, which is your hardware equivalent. So this is your actual, the information that's being used to program the ASIC for any mirror sessions or endpoints configured on your switch. Resources basically amount to the AOS-CX monitoring guide. This is where the mirroring configuration is for AOS-CX. And that is all for mirroring enhancements in AOS-CX 10.7.